Welcome back to my YouTube channel called Sharmio. In the last two videos, one was explaining the difference between Karpenter versus cluster autoscaler, and in that video I tried to explain complete comparisons and some more in-depth analysis. Where does cluster autoscaler is more right appropriate fit over Karpenter, and so on. And after that theoretical session, in this video I walk through the whole process, step-by-step guide to install and configuring the Karpenter on the EKS cluster when you have the EKS cluster is already installed. Because if you just simply go to the Karpenter documentation and click on getting started, and this is the challenge which I've seen in the documentation, they only provided two different approach. One is you already have the Karpenter you're installing when you're creating your cluster, and the second approach they have is when you're migrating from a cluster autoscaler. What they have not included in the documentation, what if you have a cluster up and running in AWS, which is EKS cluster, but what you don't have is neither the cluster autoscaler is installed and you have not configured the Karpenter at the time of creation of that cluster. So that's what I try to cover it up in here, because the other two documentation is very well clear. But if you still have issue, I would highly recommend to watch this one. At the end of this video, what I also did is I actually try to include some important concepts called in Karpenter called node pools and node classes. And now in this video demonstration, I will be going through and explaining both of them and how does the node claim will be working on. And we will take some use cases. I'll just create some random use cases and we will see how do you configure your node pools in order to accommodate those changes. All right, so as you can see, my cluster is up and running, which is 1.31, and everything's looking good. We can ignore the upgrade inside. It's just tell about like whether one of your add-ons is not compatible with the versions. It's 132, so this is about the observability dashboard which they have released recently, so we don't need to worry about. We can see just because this is my sandbox environment, so there is only one T3A medium node group is this is the node group, and this is the node which we can see. Also you can see the networking versus the add-ons, so everything's including the EKS pod identity agent is all up and running. So now what we'll do is I'll actually bring my VS code into the picture, and I'll actually just gonna make it comparison. And what I'll also going to do is I'll increase my VS Code font, and I'll just gonna make this. Now firstly, let's do one thing before we jump into anything. I also bring my terminal into the picture, so let's just bring the terminal. Okay, so first thing first, I'll firstly export my profile in AWS, and I'll also increase the font for you guys so that you can actually see. So if I just run the AWS SDS get caller identity, then it will show me that what role or user I'm using. So I'm already logged in with the right users, so that means I have access, and I can confirm by just typing, does it have any bucket inside this account? Yes, I do. So you can see there are a couple of buckets. So I do know that I have the access, and currently I have given myself, because it's a sandbox account, so I give this account almost a full administrator access, so I don't have to worry about. Now the first thing which we will be checking is we will be checking how many pods is all the pods running. Yes, and here you can see there is no namespaces apart from kubesystem, because I just installed this cluster last night before making this video. So because EKS clusters can be expensive, so if you just leave it over a month, so depending upon how much budget you are setting up on your account, so make sure you always check your builds as well as the cost. All right, so now here the main ones is these two pods, which we can confirm they are up and running fine. And let's just try to do another thing, which is called kubectl node pool versus let's just run the node pool. So you can see there is a one node pool which is called default is running, and if I just type kubectl get node class, let's see if it's okay, it's not classes. Nope. Okay, let's just see from the lens what they call. it's called kubectl get node classes, EC2 classes actually. So here we can see this is also running. Now to make much life easier for the users, what I'm gonna do is I'm not gonna use a lot more of the command line. I will be showing through the visualizations using Lens. Now Lens is open source, plus now they have another paid tier you can go for. So if you just type Kubernetes Lens, it's a great way if somebody wants to leverage see any of your Kubernetes manifest versus resources. So I can put this link, you can still use it for free even if they have a pricing models you don't need to worry about. So here we can see, if I just minimize this, so I've already connected with my sandbox cluster, which I'm just showing here. So as you can see, if I just include all namespaces, the same results which we have just seen from the terminal. Now here you can see I have one is the node class and one is the node pool. And we can see there is another things Karpenter also have in the custom resource definition in node claim, which is currently empty. So first thing what we'll do is, let me just delete it because I don't want to use the default one. So I'm just going to go here and delete both of them. And I also increases the size here. Okay. So now as we can see, there is no node class versus node pool exist. And now what we're going to do is we're just going to come here to this VS Code. Now node classes is in a simple term in relation to Karpenter is nothing is where you define what sort of your image you will be using. Like you can specify with the selector. So as you can see here, I'm using an AMI selector for alias for Amazon Linux 2023. So anything related to in the node class where you provide like the security groups, subnets, the role you want to use, and the AMI, which AMI will be using to provision that node. So that sort of information goes inside into the node classes. And node classes just job is nothing by itself unless this node class, once we create it, we need to point it to the node pool. So because in the node pool, you're going to have multiple different type of nodes to be used, but the type of the AMI or the selector for AMI family, the subnet, if you want to use a specific instance profile role. So those all information going here. And the best thing to explain it more clearly is just by looking here. So if you just look at here, so you can see there is a lot more specs you can go for. So you can set up a kubelet informations if you are going that deep. Similarly to AMI family, whether you want to use Amazon Linux 2 versus Amazon Linux 2023 or the Windows 2019 versus 2022, you can bring your own custom AMI. Similarly for the subnet selectors, security groups, instance profile, as I just mentioned. And there is so many different level of granularity of specifications you can go for. And for the time being, we will not going to go all into that, but you can actually have a look, whichever is relevant to your need, you can. But ideally, most of the time, you will be just providing the AMI selectors. Metadata options is good to have that you are using the turning it on. Role would be important if you are using a specific Karpenter IAM role. So in my case, yes, I am. And the security and subnet. So it's only the very minimal essentials I'm currently using in. So now what we're gonna do is, so this is already exist here, and what I'm gonna do is I'll firstly again export the profile here, and now I will just gonna run kubectl apply where in my Karpenter folder under the node class. So now just to see here, I'm not calling my node EC2 node class as a default anymore, and the default one we have already deleted. So now this is called as a Karpenter node class. So the moment if I'm just gonna apply, if everything has been configured correctly, so as you can see, and we can actually just check here itself K is just the alias, just in case if you think what I'm using here. So I created an alias in my terminal. That's how I'm just using it. And just if we just type right now, so you can see it's 16 seconds ago it's created. Now the same level of informations we can see directly from Lens as well. So I'm just going to show it from here. So as you can see, the status is ready. It has already added some automatic annotations, and this is everything's looking good here. So now the node class has been already exist and created fine, right? So we don't have any problems. So, and we are just using an alias to be 2023 pick up any AMI, and then we just using the roles and the subnets, some of the configurations. Now in the case of NodePool, if we just go here and see the NodePool, when you install the Karpenter, as you can see, if I just zoom in, you set up with the default NodePool, which as I showed you guys, so we are not using anymore that NodePool, and the NodePools set a constraints on the nodes that can be created by the Karpenter. Thinking of a simple term is node class is doing nothing, it's just creating your EC2 AMI. You're telling in a node class definition which EC2 AMI version of the family to be used with which networking configuration. Simple as that. While NodePool will be leveraging that node class definition and then creating all the nodes in using that node class definition. So let's say if you say in the NodePool, I want to have 5 nodes, then the node class will be defining what type of, whether it's a Windows, Linux, and also the family of it, of AMI. So that's where the NodePool do. And now in the NodePool, there is a lot more information. So if we just come here, back to this one. So first, as you can see, there is something is set up as a disruption. So disruption is like a where you, if you see here, the disruptions were set as the budget as node equal to 10%. What does it mean is like where we provide Karpenter can actually start disrupting and replacing the nodes. Now, all this information about each specification you can actually find out through the documentation as well. So here, if we see, we are just setting up the leveraging the API version kind NodePool. My name of this NodePool will be, I'm calling it a Karpenter-NodePool. And the disruption budget I set to be node 10%. What does it mean is 10% is, it means is the budget actually going to be used for your Karpenter to scale down your nodes based on the budget that you're setting up. So if you set up like a more higher budget, and you can actually here on top of it, you can actually set, hey, I want to have a like a increase or decrease the budget based on weekdays versus weekend, depends upon if your business requirement for your company or the organization is that you really wants to have more amount of workloads to be running up on the weekdays but not on the weekends. So you can set up all those through the budgeting. Now there is other things is consolidation, consolidate after, and also the consolidation policy. What does it mean is like if basically in case of this one, consolidation policy means is if you say currently I selected as a when empty or underutilized. So basically what does it mean is it's the Karpenter will be looking for this and thinking it will try to consider all the nodes for consolidations or try to attempt it to if he find that some of the nodes are empty or underutilized. What does it mean is just think of, let's say you have 2 EC2 nodes running on your EKS cluster, but one node is completely almost empty and the second node has some space to fill up 1 or 2 port which is running on another one, then it will try to consolidate that. That's what Karpenter will be looking to do it through this policy. You can set it up to empty versus underutilized, so different, and that level of specifications will change for each Karpenter version. So making sure, currently I'm using Karpenter with v1.2, so make sure you always check the documentations which version you're using. Now in the NodePool, you also need to define like about your limits of your resources as well as for CPU and memory. So here I just set it as 5 CPU and 10 gigabyte of memory. What does it mean is my NodePool will not gonna go and try to spin up X amount of nodes to be going over 5 CPU or 10 gigabyte, either one of them. And why is not? Because of this limit I said. If you watch the last video, which I explain in installation from completely from scratch about Karpenter, you will observe I got up to M7 48 times or 24 times extra large, and it was gonna be costing me around more than $700 because it's trying to fulfill the need. So it's always important you have set up certain limit constraints on your node pool. Otherwise, Karpenter will see whatever the workloads coming in your application or in your cluster, and it will try to fulfill it. And just think about it in use cases. If you have a breach comes in and somebody's trying to spin up hundreds or thousands of EKS pods to fulfill some application needs, Karpenter will do it. So you make sure you always put some limit constraints on what's the maximum CPU and the memory you can go. Similarly, as you can see, we also have something called expire, which is by default is set to your 720 hours. What does it mean is that a node pool will usually Karpenter recommends to have that you don't run the same EC2 node for more than that much time because of any security vulnerabilities or anything else can cause the issue. So ideally you can just change it. What this is going to reflect means is that if you change it to, let's say, 1 hour, so every 1 hour Karpenter will kill the old EKS node and try to spin up the new EKS node. So 720 is almost equivalent to I think 30 days or 30.5 days. So yeah, which is fine enough, as long as it depends upon if you're going for spot versus demand, and we will be looking into that too. Similarly, here you can see the NodeClass reference coming into the picture. As I mentioned, NodePool cannot do anything by itself. It depends upon NodeClass. In the NodeClass, we provide your AMI, what type of AMI we want to use with the security configurations and the subnets. So here we have provided that, and we need to reference that one. So when NodePool is spinning up those new nodes, can use the same class definitions which is provided here. And in the requirements, as you can see, I provided AMD with Linux. And this is some of the default configuration. So here you can see currently the capacity type are set to on demand, not to spot. So we will be seeing when the node claims will be coming up, how does it gonna look like. And here there is three different instance category or the families has been selected, which is compute intensive, memory intensive, or the general purpose, if you see. So CMR, different instance categories are into the picture, and they're just selecting the instance generations, which is second version. Now let's do first thing. Here what we'll do is, like, let's just run kubectl apply, and here I'm just going to Karpenter NodePool. So the moment I just gonna apply it now, as you will go to the node pool, you can see there is a new node pool has been created, and we can see it already. Now you may be also wondering what is a node claim, because you can see there is a node claim into the picture as well. So basically node claims comes up when a node pool is actually pushing out and provisioning one of new EC2 node, and that will be, you see the definition on node claim. So we don't create the node claim by ourselves. We only do touches the provided the definition of node class and then the node pool, and then the node pool will be deciding whether, based on the definition of whatever the specs we provided here, the node claim will be coming accordingly, and we will be seeing that information. There is a really good node claim role and information has been provided here. So I would highly recommend to go through their doc, try to see if something's you're not clear. I'm not a promoter of Karpenter, but I'm just saying, like, if you have any questions, feel free to reach out to me on the channels or on my LinkedIn. Now, coming back to here, now, if we see right now the pod versus the node, we don't see anything is changing. So how do we validate that our stuff is, what's the node pool and the node class we have created is actually working well, right? So the first thing we need to do is we need to create some higher demand of application so that we can see that the auto scaling is working, because that's what we're trying to solve here. So we install the Karpenter as auto scaling. Now we have created the class definition of node class, and we also created the node pool. But now we want to validate. Now, first thing we know, when the node will going to come, if we put some applications or higher demand, that it will be going to be on demand, can't be spot. It's going to be Linux AMD base, leveraging this AMI selector. And also it cannot goes over these two limit, but also it's gonna be from one of these classes. So it's gonna be either C, M, or R. So let's do one thing. Let me see if I remember any of the commands. Let's just try to see if I can create Nginx. If I remember this command correctly. Okay, no. Let me see if I have, I think here. Okay, here you can see, okay, finally I have one thing in remember. So, okay, let's just paste it here. So what I'm doing is I'm actually creating a deployment of Nginx. We don't care about the deployment right now. What we care about the functionality of the node pool will be working with the node class for the Karpenter or not. So first thing is we can see it's just having memory is currently 20%, CPU is 2.9%, but you can see it may be underutilized. It's have a capacity, but it's not been allocated because it doesn't have pod enough to do the work. So it's Karpenter is fine. Now the main thing we need to note is if I'm gonna do 200, we know the 200 pods will not able to be all going to come alive here. So in order to test it out, let's see what's going to be. Okay, do I need to provide the image? Let's see. Okay, so now we can see there is a new pods comes in. So ideally we should see some of them will be in pending, as you can see in pending, because not everything will be able to fulfill within here. Now the one thing which we have to see is node claim. So you can see right now node claim has come up automatically. Now this node claim is coming into the picture, and here you can see the availability zone as well. And capacity, as I mentioned, it's only going to be on demand. The reason it's only going to be on demand because we put it here, the on demand. And here you can see the instance categories C, M, and R. So let's just do one thing as well once this is going to be. So I just removed the C. So the next time I would be only seeing some new EC2 instance coming up from the M or R series. And if we look at here, so you can actually see the AMI it's using versus in the zone, and the reason it's installed a very higher extra large because I have suddenly Karpenter noticed that there is so many pods. So as you can see, there is 211 pods coming into the picture, and you can see right now, even it's right now it's not able to fulfill all. So if we check to the node, so we can see right now there is one, this is the 51 seconds with 4 CPUs and almost 8 GB of RAM is being currently provisions to provide those. So let's see like how long does it actually take. But you can see right now Karpenter is not able to fulfill all of them, but at least we know that it's trying to fulfill, because it's suddenly I just created 200 replica pods. Previously it was only 11 pods, and now it have 211. Right, so let's just quickly see here, and this is all looking good. Now what I'm gonna do is and this is where we are actually playing around the functionality of Karpenter to see how quickly it can spin up versus scale down. So if we just type git deploy under the default, I think I created under default. So as you can see, currently it's only able to fulfill 64. So it's probably trying to understand that can I do it within the sim 6a large, or do I need to spin up more? But now what I'm going to do is I'm just going to interfere, and I'm actually going to delete this Nginx. Now the moment I just deleted, and if you go and check the pods, you will see it's decreasing that number right now in live. That means is ideally that node should be deleted as well, because now there is no much urgency or any demand for anything to fulfill. So let's just see if that happens as well. So currently, as you can see, everything is terminating. And by the way, if a Karpenter feels, and this is where the underutilized comes into the picture, if it's empty versus underutilized, then just consolidate and delete it. We don't need it. So that's what it's gonna see. And if everything's looking good, Karpenter thinks, nah, I don't need this node anymore. So it will actually going to terminate within a matter of few seconds more. So now we can see again, we come back to 11. Now, behind the scene, if we check on Karpenter, we probably can find out some of the information that, so here we're just seeing some of the could not schedule, that's fine. But let's just see if it's actually just go to the node and see. It maybe takes like and that's where you can see how efficient Karpenter is in a real time when you're spinning up something, scaling down. How long does it take overall to actually delete that node when it's not using? As a human, you can already pick up, I'm not running anything anymore, so it don't required. And here you can see it's still, so that means is you're still paying for it. And this is what we don't need to pay for it, but it's still going to charge you for even a matter of time. So let's look at here into the node claim, so we can still see it's here ready. And if we just could do one other thing I want to show you, let's even see here if and the moment when it's actually going to be deleted, you will see a taint will come up into the picture that nothing is going to be scheduled on this node before it can be deleted. So that's the very important thing you always have to remember. And here, even if you just click on the expand labels, you will see all the labels coming from Karpenter. So you know this is coming from the Karpenter is the one who is responsible for provisioning. And here you can see currently nothing running apart from 3 pods. So, and here is just running EKS pod identity agent and AWS node and kubeproxy, which are just the daemon sets. So now it may take time, but one thing you can actually do is like now let's do one thing. As I mentioned, first thing is I remove the C and I now only have M and R series. Now other thing is I'll also change it from on demand to spot. One thing I just want to check is on demand versus spot is it's called just spot, so it's not just the on. So this is looking good. So what I'll do is I'll just gonna modify now this to the Karpenter NodePool. So now I just modified this. So now I am only taking, because on demands are expensive, if you guys know, and here you can see now Karpenter has detected that this node is now on idle, it's not using anymore. I don't want to run it to overpay, but you can see it takes a while to do that. Now you can actually tweak that configuration as well about here within like consolidate within like a 1 minute, and as you play around you will get more idea about it. And anything by default coming up here, if it's so for example, if you don't set up these like a consolidation versus consolidation policy, and here you set expire after 720 hours, which is I think almost 30 days, then it will be going to be there for at least 30 days. So now you can see that pod is gone. And if you click on this one, you will see that this is not coming from Karpenter, because this is I created through EKSETL before the class or the session. So now we are looking all good here, right? So as you know, now our node pool has been updated. Now if we check here to the node claim is also gone. So that's great. So that means it's all looking good. Now what I'm going to do is, again, we will just gonna create the Nginx deployment again, 200, but now we should see only something coming from M and R series and should be spot based only. So let's see that happens or not. We will find out in a matter of time here. And while this is happening, so here you can see M5A D large spot comes up. Now here you can see it currently we specify to, it's automatically picking up AP Southeast 2B. And you can see now again I have 208 pods, and it's just all, some of them are automatically coming up. And here you're probably gonna see that there is another node comes up. Okay, here you can see, so it's not ready, but it will be going to ready soon. And this one is using, again, if you just click on the labels, you can see provisioning from Karpenter with M5AD, and we know it's a spot type because we removed the on demand. And that's the beauty, that you, in a lower environment, you can actually just set up to be use certain types. So here, this is my personal recommendation based on my industry experiences. You, rather than putting the M or R series or C series or any other series, I would recommend to go for a specific instance types which based on the spot with the least interruptions they happens over the time, depending upon which region are you. And I'm pretty sure if you just even type here AWS spot interruptions table frequency, you will come across one or two here. This is the instance advisors, and it's just pretty great. Like, to be honest, all you need to do is, if you try to running it on a lower non-production environment, you want to reduce your organization's cost, and the best way to reduce the organization cost is by moving to spot if you are especially in the AWS region. Not sure why it's not loading right now, but it looks like some sort of a bug is happening. But this is the page I can link you guys. And I already know in Sydney region, M6 CI versus M7Is are really popular. They are least frequent and interrupted based on my region. So I would just suggest, when you're going for a spot, pick it up, have some experiment, play around, and it's non-production. So even if sometimes, and they are sitting on an autoscaling, so it's not going to cause an interruption to anyone, but you prefer to have something more stable even if you're going for a spot. So that's why I don't use M6 or just a random series. I just go and find out which is the cheapest versus the highly stable I can use. Now, one other thing is, which you currently don't see here, is I will also add something called topology. Currently, because I'm in a city region, so if you just see, for example, so I currently just added one topology. By default, if you check here, this node, which is M5D, and if you can see in the node claim, this is using spot zone 2B. Now, ideally, you don't want to have the node pool to be only putting up in a one availability zone. If you're in US, depend upon which region are you on, you might have more availability zones. But if you are in Sydney or like any other Asia Pacific regions, you might have a less amount of availability zones. So if I just put 2A just for this demonstration so that we can see that it's actually working and not putting any more spot instance on this one, we can see. And let's do another thing. Let's just remove M as well. Now, because we are putting spot, be very careful. Sometimes it might possible that spot is not even available in that region when you're trying on, but we will find out. So let's first do one thing. We delete the, I'm just going to delete from here because I already have a command running. So now we have already deleted. It maybe takes 5 minutes to eliminate this one, and we will see all the pods are decreasing now, so, which is good, and the node claim will be gone away. Now, if we just come back to here and apply for reconfiguring the node pool, so now I just reconfigure. Only the two changes is I remove the M series, so I should not be seeing any more in the node claim, any more M series, and I will be seeing AP Southeast 2A in R series because that's what I have configured. And the whole list about all this node pool specifications, you can actually, again, going through the document, you will understand. It's pretty straightforward, very easy. And now here, if I just Firstly, let's just quickly check if the all the pods has been gone down. So yes, it's gone down, we don't see anything. And here you can see Karpenter has detected the interruption, so it will be going to eliminate, and boom, it's gone. So that means is if it's gone, that means the node claim is also going to be gone, which is awesome. Now let's try to create the same Nginx again. And I'm just doing it so that we can actually test the capability of Karpenter. I'm just using Nginx, but in your cluster you might have a different applications you want to play around, and you can create as many node pool. By the way, you don't have to create only one node pool and one node class. So you can have a one node class for, let's say, AMI for 2023, and you want to use specific role versus with the security subnet configurations. You might have one for Windows, you have might one for AL2 versus AL 2023, and then you can create a node pool for you want to have a higher interruptions versus consolidations for journal purpose versus some are memory intensive. So you can just play around, create multiple node pools versus node class. You don't have to be, you're not obligated just to have one. All right, so you just make sure you just go for it. So now I just created this, so let's see what does the node claim will be going to look like. So we should see now, as I mentioned, now we're going on a very specific instance. So we said we wants to go for R series, and we said we wants to go for an AP Southeast 2A with the spot capacity type. Now it may takes a while for a Karpenter, and now this is loading. So if we just check here, if we go to the Sydney, and here let's say we provide 4, and here we provide 8. So here you can see these are the frequency, and let's see any of them is in R series. So let's just see if I just type R. So here if we just go see, there are so many of them. So you can see like there are some of them are available in the R series as well. So for example this one, so you can see what's the savings will gonna look like for the R6ID and extra large, but the frequency of interruption is 15 to 20%. What does it mean is that even if you select this one for in your node pool, you know the frequency of interruption is going to be high. That means that node in that availability zone or in that region will not gonna be making sure that your application will be reliable. So I usually recommend to have less than 5%, go for it 5 to 10, but just make sure you have some combinations with less than 5% to be involved within it. So let's see if it's able to claim. So as we can see, nothing coming up. So it doesn't mean that you have a wrong configuration. It means it's like it's not possible for it. But so let's just do one thing. Let's just make it M as well, because I know M's are general purpose, so they are more easier to be comes alive. So now I just added M as well. So hopefully it may come up soon now in M series. But again, as I mentioned, we are specified for in availability zone 2A only, as you can see here. So here you can see M series is available, boom, so it's come up, but R series not coming up. So this is a really good example. You can see that if you just specified only one instance category with the spot instances in a specific availability zone, you may be in luck, you may be not in luck, but you can't rely all the time. So that's where you need to have looking at two things. First is which instance series versus what you like to use. I usually like M series for general purpose workload. So if you are just going for a general purpose workload, so here you can see currently in Sydney the interruptions are really high. But if you go for, let's say, M7, so you can see, for example, M7i flex is currently less than 5%, M7i 24 is 5 to 10%, which is still okay. And similarly, the interruptions depends upon which are more popular in the spot. So they usually sometimes cut it off in that region, because they try to put it the ones which are not all the time is popular, so that it can be from a business standpoint, so they can save money. So yeah, so as I was saying is like you make sure you have added a couple of type of your instances If you're using only Spot, you can mix it up on Spot versus demand on demand. But one thing I noticed when I tried that, most of the time on demand is coming up, because Karpenter, sometimes I think the algorithms try to think is like, I'm having more better visibility quickly to bring the application live back and schedule those ports which are stuck in pending. So I'm going to go for the pod. So, oh, going for the on demand. So that's the only thing which I noticed. So that's where I'm saying, if you just put a specific instances types and then you just go here, that would be much better for you guys. So make sure you always check the frequency of disruption. If you're using on demand, it doesn't matter whichever the ones you like to use. And yeah, that's pretty much it. So now I would just say, and ideally also you shouldn't be putting one, you should be putting all availability zones so that it's not restricted in one. And now I'm just gonna delete my nginx because I don't need it. I hope you guys get some good understanding about Karpenter now. Karpenter is similar to cluster autoscalers, but it works in a different way where you have some more leverage. Only my standpoint or opinion is that if you don't set this, you're literally going to have a cry for the cost, because it can go crazy if somebody within your company or team, or if your cluster is exposed somehow and somebody is deploying multiple applications workloads. Karpenter trying to fulfill that need, it's not going to care unless you have the limits in place or some sort of alerting in place. So making sure you always be careful when you're playing with Karpenter. Having said that, that's pretty much it, guys. I would highly recommend, before you watching coming to this video, please check it out, Karpenter versus cluster scaler and installation. And then this is only about NodePool versus NodeClass, and how does NodePool actually leverage the node claims. And in the next video I'm thinking of, I will be going for how do you upgrade your EKS cluster from previous current version to the next version, maintaining the application reliability and durability without impacting in a zero downtime. So the same process, you can actually do it in production, because I have done it hundred of times in the past in different companies. So I will be showing you guys on that one. So it's a simple method you can leverage, and we will be just doing that way. Having said that, have a wonderful weekend, everyone, and I hope you guys find some valuable lessons today. Bye.